So hello everybody. Thanks for being here today. My name is Albert, and together with Antoine, we're going to be talking about LLM-based reasoning on your business data. So first of all, we would like to thank InnoIT in general, and in particular Jerome and all his team for giving us the opportunity to be here today and share with you a bit about the new things that are happening in this domain. So basically what we try to do today, so our goal is trying to talk about this topic, and we want everybody to go home with something new that you learn, right? No matter if you are just starting in this domain or you are an expert, we hope, our goal is to provide something meaningful for all of you. If at the end of the talk you don't get anything meaningful, don't worry. There's going to be pizzas and beer afterwards, so it's going to be worth the wait. So Neosoftia. So that's the company that we recently founded, and our goal is trying to empower the small and medium enterprises to use artificial intelligence, right? So we all know that nowadays artificial intelligence is kind of in all the headlines, and these are tools that can be very useful for many enterprises. But what about the SMEs, right? We want them also to be part of this revolution and to also take advantage of these tools. In my case, as I said, my name is Albert, together with Antoine. We've been working with artificial intelligence and ML technologies for the last 15 years. And just recently, we've been also more involved into generative AI, because it's a pretty new field. So I guess that it's very difficult to say that anybody's expert in that field now. It's very, very recent. So we try to do our best to explain a bit how it works and how we can use that in our business. So that's the agenda for today. We will start by giving a basic introduction of large language models, what they are and how we can use them. And then second part is going to be, okay, those large language models are very nice, but can they be useful for my business? That's what we're going to be seeing here. Then we will see different ways to adopt those LLMs into the business in particular. And then we will go through the Retrieval Augmented Generation, which is also called RAGs, which is a way, it's a nice way to, or a nice strategy to actually use those LLMs in a particular domain. We will see the details on how they work. We'll see that they have some limitations, and for that we will need some more advanced techniques. And in that sense, we will go to the section of advanced RAG. Finally, there's going to be a section that we call essential extras. That's an oxymoron, you might think. But we believe that what we're going to present there is pretty important, should be there always, but it's oftentimes overlooked. That's why we call that essential extras. Finally, we will conclude the talk, and hopefully there's going to be some time for Q&A. If we don't give enough time, there's going to be then the networking, and then feel free to approach us and we can discuss anything that is not clear or talk about it. So large language models. I'm going to be giving the floor to my colleague Antoine.
So, thanks. Just to test the audience a little bit. So I guess a lot of people here have already tested ChatGPT. I don't know how many of you have already tested ChatGPT. Yeah, almost 90%. How many of you knows what exactly is a large language model? Yeah, okay, 40%. And how many of you also has a plan to test large language model or to introduce large language model in your company or in your project? Okay, so it's a very good 40% of intention to use that. So I think that's good. So around the definition of large language model, so what is an LLM? I mean, I'll try to use an LLM to answer to that. So I'm going to prompt that, because now it's what we are doing in prompting. So there is a prompt engineering in our jobs. So the prompt is, okay, I'm going to the most famous one currently, OpenAI, and I'm going to ask what is an LLM in simple terms. So this is the answer of ChatGPT. So LLM is like a super smart robot that has read a vast amount of text from books, blah, 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 blah. And now when you ask it a question or talk to it, it uses everything that it has learned to come up with a response. It also says that it's not perfect, and that's true. It doesn't know everything, blah, blah, blah. And it's like having a knowledgeable friend who's read a lot of books and can chat about a wide range of topics. So I guess we all have an LLM friend in our close groups. But in that definition, it takes about a vast amount of data, and that's mostly the most important part of that definition. It does not really indicate how it works. If I ask the LLM, okay, now try to give me that definition in a visual way, because now this kind of solution has merged border of different modalities. It's not just about text of image. They can combine the both things, text, image, audio, and video. So I ask it, and that's what it creates. So I didn't change it. So this is the response of the OpenAI. So there is still this book, this huge information that the robot has read and try to explain to this kid. So it's not perfect. Actually, it's reverse. So I don't know why he did it. I didn't did it on purpose, but that's what it does. So, well, that's not the definition I was looking at, but there is that vast amount of data as a notion of a core in that LLM. As a game, I put here a response of ChatGPT. Imagine a magical donut soaked in beer, which has read every book in the world and can chat with you about anything, just by munching it. And I propose you to guess the prompt. I don't know if someone has an idea of what the prompt would have been.
Make a joke. What is a LLM explained by Homer Simpson?
Whoa. Explain what is an LLM to Homer Simpson. That's almost exactly the same. So yes, that's true. That was my first prompt. Actually, that was not the first answer. The first answer of the ChatGPT was very long, so not good for the presentation. I tried to interact with the LLM. I tried to do my prompt engineering and interaction. I said, oh yeah, it's great, but make it shorter. It did it, but it was not exactly what I wanted. And actually, I did that prompt. I interact to get my answer, and that's a lot of part of the system is about also prompt engineering and how to interact with that system. So still, we don't have our good definition. So I'll try to look in that another source, and that's what I come up as I think a good definition of what is exactly an LLM, and it's for me it's a highly sophisticated statistical models that learns the complex probabilistic structure of the language. It's like a word predictor. So it has learned the intrinsic needs, the patterns of our language, and he's very good at predicting the next word. So we have a sentence, which is a set of words, and he's good at predicting the next word. And then with that next word, predict the next one. And that's how it generates the text. So there is not very much intelligence in that as we think. It's just a very good understanding of how we talk and the pattern, the statistic patterns between the different words. So thanks to that capacity to predict, so this LLM can perform lots of range of language tasks like text generation, translation, summarization, and question answering. So lots of down tasks are performed thanks to that high capacity of predicting new words. So where it came from? It came from so a long time ago, and so I don't know how many of you are know about deep learning and neural networks. Actually, LLMs and neural networks, and it came from the first notion of neurons came from the 60s by Rosenblatt, and this is a perceptron. This is one neuron which transforms one input in another output by multiplying some weights. The weights, in a sense, contains all the information of the function. So all the information of the knowledge is encoding into the weights. So this is a function that multiplies the inputs by a weight, apply some linearity function, and get an output. That's the basic of all what we're seeing now nowadays in our in this LLM and deep learning. So this came in the 60s. Then after a lot of cooking, okay, I'll put that neurons like this. I create different patterns, different structure of neurons. I came up more complex CFI. I put different layers, some convolution networks. That was like about cooking and creating some smart infrastructure of neurons. We came in the deep neural networks era. And yes, at the end, we have a huge amount of neurons, smartly architectured, which creates universal function. So we can basically map to any function that we want. We had our first revolution, which was more on the computer vision. With 2012, there was the imaginary classification with the deep convolution networks. That was the first revolution, I would say, on the deep learning. And then comes on 2017, the start of the NLP revolution, I would say, with this famous paper, Attention is All You Need, which set up the transformer architecture, which is basically what we use, what is being used now into the different LLMs. And this architecture, so it's a high-level view. Inside of this, there is that kind of neurons that we've seen previously in the previous slides. So I will not enter into that that architecture, but we will let the link here. Very interesting way to put some layers of neurons to create a great transformation between input and output. And then, so we passed in the 60s with 4 weights, and to now 1.7 trillions of weights on the GPT-4, which estimated because it's not officially told, but this is what we estimated that there is. And now also we are in the hype of large language models. So I borrowed that slide and to these persons. Actually, here what I wanted to show is that the end-to-end public mostly knows about 2023, where ChatGPT really came into the end consumer public. But there was a lot of before LLM on the market on the result that was being created. So 2022 is like a pivotal year in the LLM, and yeah, we've looked to different kind of LLMs. Some are open source, some are proprietary. Each has his pros and cons, but they are exploding in so many sense. And what are the trends now? Actually, the trends, so the big team creating that models go for, as I said before, multimodal, no? How to merge the text, the vision, and recently the video, so that we can so that this LLM can understand the type of video, so that we can query in different modality this system. So as an example, GPT-5 will have a lot of features that merge these different modality. We also have this training, so it's not about only have a bigger model and a bigger model, because these models are less easy to install in your own premise. So there is still some huge trends in staying in now what they say is a small model, which was before the big model. Now they are small, the 7 billion kind of model, like the Mistral or Falcon or Llama. And there is a lot of companies also working on this model to enable companies to install it in their system. We also look to very niche kind of models. So like in finance, the Bloomberg GPT or the healthcare Google's MedPalm, which are fine-tuned specifically for that for that kind of areas. Also, there are some models that are looking for freshness. So this is difficult to train data and always be updated. And if you prompt the ChatGPT or the GPT-4, they would say, "Oh, I don't know that answer because my cut of time is I don't remember start of this year." So it's hard to make to keep a big language model updated, and some of them are trying to fulfill that restriction, like the perplexity, which has a lot, which has trained on very new data. And also there is a train of AI agents, so using that LLM or another kind of architecture to create more powerful tool based on agent and looking for what they say the general intelligence. So that's the streams. And if we go a little slide to understand how these LLMs are trained. So we're going to see there is 3 big steps for training that foundational models. And the first one, which is let's say the biggest one on the term of data. So first is pre-train on a large chunk of data using self-supervised learning. So the data is having the input and output. We're trying to predict what is the next word. So once upon we mask the time and we say to the LLM, learn that the next mask is time. If it doesn't look great, we update the weights until it gets right. So we train it playing the game of guess the next word. The good thing is we can use the same text to do that training. We can use all the text and just mask progressively the sentence. And that makes that we don't need annotation here, and we can use all the text that has been written into and posted publicly into internet to use that. So if we have enough power, we can do self-supervised learning. And this creates a structure that knows the patterns of the statistical pattern of the language. Then here we didn't put any downstream task. Just we let the LLM try to learn the statistical pattern of the language. And then we fine-tune it with the downstream task. We have a task of instruction fine-tuning. So we show the LLM how to answer the question. If we don't show that, when we ask the question, the LLM will try to follow the question, will try to predict the next word, which could be the next part of the question. So what we want to do is say, no, you know how to guess the next word, but now I will fine-tune you to solve this task, which is answering my question. And this is done with more supervised learning, more old school machine learning. So we have our data set of input and output, and we fine-tune with that task. And it could be different tasks. It could be question answering or summarization. Here, it depends on how the LLM has been fine-tuned. And then there is another part, which is we align the response of the LLM to the preference of humans. So we let the user use the system and fine-tune the answers, or fine-tune how the LLM behave according the user feedback. And this is more online learning, more done by reinforcement learning. So these are the 3 steps that make these foundational models so good at what they do. And so this is more about where we come, the deep and how the LLMs are being. And so where are LLM good at? So there is a lot of use case actually, and we try to let's say summarize. It looks like a summarization of the different use case of where the LLMs is good at. So on all the use case, the one that I've seen a lot, and it's customer support automation. So there is a lot of LLM chatbot now that they extend the capabilities with LLM. Why? Because chatbot is engaging with user with text, and that's exactly what LLM is good at, understanding the text, understanding the semantic. So as an example, but I could have put a lot of example more, Zendesk is having an LLM chatbot to provide customer support. Another one is content creation and summarization. So lots of use cases also, like Copy AI, which create a platform that creates blog posts based on some inputs, and the LLM, as it's good at generating text, it's good at creating that blog post based on a smart prompt done on the platform. Also, a nice use case, BBC use another platform, Charisma AI, to create interactive stories. So they put some definition of characters and other tips to create the story, and the system is able to create a whole story. In data analysis, so all the legal and finance that works with lots of unstructured data will take benefit of NLM. For example, JP Morgan with the doc LLM classify all the legal finance docs and supports question answering for their intern. Personalization, Spotify is now partnering with Google to extend their recommendation, which works great on their already great on their audio, but they extend recommendation to podcast and audiobooks to understand the text which is in it. Language translation, so very good. This system very good at transforming one language to another because they know the intrinsic of this language and the other. So translating automatically between one language and another is, for example, something that it's been done in Meta platform to translate the different social media content. And as a developer, development support, I don't know how much of you are coder, but if you use GitHub Copilot, Amazon Code Whisper, I've been using that to create some snippet of code, and it's working pretty well. So there are different use cases. I think the one that are mostly observed. So there were some challenges on it. So yeah, ethical and safety concern. Ethical, I mean, they're so powerful that we may have some question on when to use that, or if it can be used for harmful content. So creating some automatic message, social message, targeting different person with LLM is something that can be done because of his power. bias. I mean, like all machine learning, but especially on this is so this LLM-based work has learned about the data. So if your data is biased, probably the output of your system will also be biased. Computational resource to create that LLM, you need that computational resource. So it may segregate to some a few elected companies that can really create that kind of system. I think one of the most important for business is interpretability and transparency. So if you can have your response, but it's hard to understand why the response has been given. And depending on your use case, you want to get that reason. You want to get why this LLM has come up to that solution, to that answer. There are solutions to that, but if you have to put that in place. And then hallucination, that's a term that they give when an LLM makes some inconsistency or when the LLM really invents what he's saying. So as it's good at generating things, it can really create an answer which looks great, which looks syntactically great, which looks also almost understandable, but it's false. And this is one of the main problem of the current LLM. So what defines a good use case if you want to implement it into your business? I would say that if you have a use case where you have a high volume of textual data or unstructured data, or lots of PDF or lots of text that you don't have that into your database, this is one point that makes you think that could be a good use case. Also, if you need to understand the complexity and semantic nuance in text, that's also a good one. If you need some to tweak things to make your output more fit to your customer, if you need personalization, that's also a good use case. Also, as if your use case is currently is needing a high effort of human generation, of manpower, and on the contrary, when you think about an LLM creating that, it's easy to evaluate if the LLM has done it well. That's also a good use case for that. If you think of a use case where it will be difficult to evaluate what the LLM has done, you probably have to get a warning here. And finally, if your task that you want to introduce LLM, it's a routing, and you want to automate that. So in the sense of automating routine type of task, that's also a good use case. Some quick checklist when you want to start it. To start in adopting or investigating, define your success metrics. If it's you want to if it's time saving, or it's process efficiency, or it's improving into your classification of the old school machine learning, put your baseline and define your success metric to start the use case. Involve from the start the domain experts, because it's usually working with domain knowledge. So don't involve just the IT or the development. Involve the domain expert that will guide, and we create a team to adopt that use case. Also, do your viability analysis. I mean, there are some risks, so you have to balance the risk that may create or may impact, versus the long-term return that your LLM can do. Look at your data availability if you want to fine-tune, and yeah, keep updated, because this is a field that is changing very, very, very quickly. So yeah, try to have an eye on it, and iterate. Start small, some use case, and maybe put your system based on LLM on a subset of users, and then get feedback and iterate on that. I think that's the things that we've learned on how to adapt that. And so that was more high level on where to use and how to use. Now we're entering more into the, I'd say, more technically how to use that.
Thanks, Antoine. Okay, good. So those LLMs seem great, right? So now how can I leverage all this power to my business? Let's see ways to do that. So I'm going to show you 4 ways, which are the main 4 avenues on how those LLMs are being implemented in a business. First one is what we call out-of-the-box LLM, right? So you just use your preferred LLM, like say ChatGPT or Java, whatever you want, and then use it as it is. So if you are building a system for your company, and your company, you've got a website, and you get lucky that that this information that is in your website was read by ChatGPT when training, chances are that ChatGPT knows about your company, whatever is public. But if you have private data in your company, ChatGPT will not know about it. That's the easiest way to go with it, out of the box. Second approach is fine-tuning. So you can adapt a pre-trained LLM to a specific domain. So what you do here is that you provide some information, some data, label data of your domain, and you update the weights of this LLM, right? That's the second approach. Third approach is pre-training. So you get your LLM with some random weights at the beginning, this 1.7 trillion weights, and you start training from scratch. So for that, that's a lot of compute that you need. So it's very unlikely that you can do that unless you work for a very, very big company. And then the last approach, which is the one that is mostly used in the domain we are talking about, right? Applying to the business, is using Retrieval Augmented Generation, or RAG, in which what you do is that you use an out-of-the-box LLM, but you connect that with an external knowledge base. So this external knowledge base is going to contain information about your company, and you're going to use this information to prompt an LLM. We will see exactly how we do that. So out of the box, the first approach. For that, you will need to do a lot of prompt engineering, as Antoine was showing at the beginning. That's prompt engineering. We define it as the art of defining specialized instructions to guide LLM behavior. We call that an art more than a science because, yeah, there are tricks that you can apply for asking an LLM certain things. Sometimes it works better, some other times it works worse, and we don't know why. So that's why we call an art, right? There are different approaches. One is zero-shot prompting, in which you basically ask the question to an LLM. So, for instance, please specify this sentence as being positive or negative or neutral. You provide the question or the sentence in that case, and you wait for the LLM to tell you that this is a positive sentence, for instance. Second approach is something called few-shot prompting. In that case, you ask the same question. Say, okay, I want you to provide me whether the sentence I'm going to give you is positive, negative, or neutral. But in that case, I'm going to show you a few examples. What is the input, and what do I expect as an output, right? And then at the end, you provide the actual sentence you want to rate the sentiment. And you provide all of that directly to the LLM into the what we call the context, right? You prompt the whole thing into the LLM. And finally, there's another technique. There are many more techniques, but these are just a few of them which are widely used, which is called a chain of thought prompting. If you ask this to the LLM, for instance, for this example, I went to the market and bought 10 apples. I gave 2 apples to the neighbor and 2 to the repairman. I then went and bought 5 more apples and ate 1. How many apples did I remain with? Chances are that the LLM gets it wrong. So, but then if you provide that and you tell the LLM, please, let's think step by step. Then the LLM kind of structures the thinking, and it will be able to provide you the good answer by just going step by step. So this is another trick that is being used for the LLMs to accomplish the task you try to accomplish. Some tips for prompt engineering. Well, first, be specific and clear. The more specific and the more clear you are, the better the results. So assign roles. You can tell you are an expert in traveling, trying to help our customers. So that's the role, and it will perform better. Give the context. Tell the LLM what we expect from the LLM. So you're dealing with customers, or you're dealing with executives, right? So the more information you give to the LLM, it will be able to adapt the answers to that specific case. Also specify the tone of the language. So tell that the LLM needs to be gentle, or if you want the LLM to be rude, depending on the situation, you can tell, and it will hopefully follow. Also constraint hallucinations. So we've seen that LLMs very often make up their answers out of nowhere, apparently, but you can tell, if you don't know the answer, just say, I don't know, plainly. There's no need to make up the answer. Also, you can ask about the LLM. You can tell that only answer if you are completely confident of your answer. Otherwise, just say, I don't know. So you can also instruct that to the LLM. And then also another trick is whenever you have a long context with a lot of examples and a final question, it's better to put the question at the end than at the beginning, right? You say, look, here is the example of things, or for instance, a text. You want to summarize a text. You provide the whole text, and then at the end you say, please summarize the text above, rather than doing the other way around. According to the literature, that works better. So these are just a few tips. You can use this prompt engineering in this out of the box, but also they also apply to the other modalities that we've seen. In any case, it's experimentation and iteration are very important, because given that this is an art, it's a lot of trial and error and trying out different things. Second strategy is fine-tuning. So you've got your LLM, say ChatGPT, for instance, and then you adapt the weights, right? So what you need to do is first you gather domain-specific data set of your business with labels or questions and answers, for instance, and you use some technique to update the weights of this LLM. But instead of upweighting the 1.7 trillion weights, there are some efficient ways to fine-tune those models. There is a library in Hugging Face called Parameter Efficient Fine-Tuning, PEFT, with a lot of strategies for doing precisely that. One of those, which is very widely adopted, is called LoRa, or low rank optimization adaptation. And what it does basically is that you've got here the pre-trained weights in this LLM, and instead of updating them, you have a couple of matrices with weights which are much smaller than this one, and you just train these weights. And at the end, you sum the weights of those matrices, and you have your fine-tuned model. That's much more efficient than training the whole model or fine-tuning the whole model. Then there is the pre-training, which, as I said before, is getting the LLM and training from scratch all the weights. That requires a huge amount of data. Maybe you need to scrape the whole internet. It requires large amounts of computing resources, only available for the big tech companies. And then again, remember that if you do that, you need to do this 3-step training that Antoine was mentioning before: self-supervised training, supervised fine-tuning, and then at the end, this human-preferred alignment. That's rarely used in practice for the companies. Now we go to our preferred one, which is the RAG, Retrieval Augmented Generation. As I said, the difference here that you've got the query, you've got your preferred LLM, and then you have an external knowledge base. So whenever the user queries the LLM, we retrieve the important information from the knowledge base, and then we provide this information in the LLM together with the query, and then we get the response. That's in a nutshell how it works. Then there are some benefits and drawbacks for each one of those systems. For the sake of time, I will not go through all of them, but because we mentioned already, out of the box is easy to use, but it's very likely that it doesn't have the information that we need for our business. Fine-tuning an LLM, you need label data. That's costly, but it can be good to find in cases where you have a very specific vocabulary in your domain. That can be very useful, but you need some resources and also label data. So you need to really balance if it's worth. Training LLM from scratch, not recommended at this level. So I go to the RAG. As we said, this is the preferred one in most of the use cases. It can reason on your business data. It's less prone to hallucinations because you tell just answer based on the information I provide to you. Don't make up the answer, right? So it has less hallucinations. The knowledge can be updated because you can keep updating your knowledge base. It's easy to interpret because whenever you have an answer, you can ask the LLM to tell you what piece of text was this answer based on. Because you have your knowledge base, you provide different pieces of text, and then the LLM can tell you, okay, this is the answer because I retrieved it from this chunk of data or from this other chunk of data. So it's much easier to interpret. On the downside, it requires well-engineered pipelines because there are many components working together. And maybe you have higher latency because there are different components for each query, so it might take more time to complete. Now, what about the costs? Here, we put just an example, just some fictitious example of what would be the cost of using each one of the different strategies. So pretend that you are working on a online retail company, and you want to expose an LLM-based chatbot that interacts with the users in the FAQ section of the website, right? So the expected traffic is 1 million messages a month, and the knowledge base is composed of 1 million document paragraphs. So we assume that in our knowledge base, we're going to chop our data into paragraphs, and so we will store each paragraph separately in the knowledge base. So if we go for out of the box, this can be a cost. This cost is based on the OpenAI